Okay, so hello everyone. We're just going to be going over this an MSAT question. So this one states that the graph of a function f is shown below. So they're showing us this graph, and it says if limit of f of x as x approaches, limit as x approaches b of f of x exists and f is not continuous at b, what does b equal? So notice how there's no numbers, so they don't want us to look for any limit or anything. What they want us to look for is a limit that exists, but it is not continuous. So we already know that there are three types of discontinuities. First of all, we have the asymptote, which is basically just going into infinity, right? So that's our first type of discontinuity. Then we have the jump, which goes from one place to another, just like that, a jump, it goes from here to here. And then our third one is a hole, which is like this, but then it's over here. So all three of these are discontinuous, but the only difference is that with the holes, they can exist. Because notice how there's still a hole on the graph, right? Therefore, that means that there could be a number there. You could get a value there. Therefore, it exists. Unlike these two, which just aren't on the graph, they're just completely different. Therefore, we can determine that this is the area we should be looking at because one, it exists and it is not continuous. Now they're asking us to find what b equals to. So if we notice here, it says x approaching b. So b is the x value we're approaching on the graph. So if we're coming on this side and if we're coming on this side and this is our discontinuity, then we would be approaching 0 on the x-axis. Therefore, b would be 0. So if we just go here, out of all these answer choices, the answer would be 0.